Good afternoon, everyone. My name is Kui Liu, an agronomist at the Soil Current Research and Development Center. Today, I'll talk about a system approach to assessing cropping systems on the Canadian prairies, focusing on yield and economic returns. First of all, I'd like to thank my collaborators for their great contribution. Second, I'd like to thank technical support. Without them, this project couldn't have been done. And third, I thank financial support from multiple producer organizations under the CARP program. Agriculture is facing great challenges, such as food insecurity. For producers, they're most concerned about the uncertainty of their net incomes. In addition, modern agriculture often reduce the biodiversity, which have negative impact on the system resilience. We know that soil degradation and environmental impacts are challenges for agriculture. From last year's drought, it's clear that agriculture is vulnerable to extreme weather. So how to address these challenges? We need to adopt a system approach because the cropping system is intensively managed agroecosystems. Its cropping system interacts with their surrounding environments, such as soil and climate, and then provide essential ecosystem services. Because the cropping system environment interaction is so complicated, therefore multiple indicators should be used when assessing cropping systems. In this study, we use a cropping system approach. We use a system approach to assess cropping system with the goal of developing productive, resilient cropping systems on the Canadian prairies. We will evaluate crop production, resource use efficiency, soil health, weeds, disease, environmental impact such as carbon footprint, economic returns, and system resilience. This study was established in 2018 at 7 sites on the Canadian prairies, including Lethbridge, Lacombe, Beaver Lodge, Swift Current, Scouts, Milford, and Carmen. Among these 7 sites, 5 sites indicated by these blue stars are fully phased sites. And these Lacombe and Beaver Lodge sites are single phase sites and will be converted to full phase sites this year. Also, we add Brandon as additional sites start this year. So that means in 2022, we will have 8 fully phased sites. This provides a great platform to study how cropping systems are affected by different soil, different climate conditions. We have 6 cropping systems, that's 6 treatments. The rotation 1 is conventional cropping systems using as a reference or control. Rotation 2 is intensified cropping systems, focus on pulse and oil seeds. Rotation 3 is a diversified cropping systems. In this system, we have multiple crops. In the 4-year rotation, they have 4 different crops. Rotation 4 is a market-driven system. In this rotation, the crop selection is solely based on crop price. Rotation 5 is a high-risk, potentially high-reward systems focused on introducing new crop to different study region. Rotation 6 is a green manure focused cropping system. This rotation focuses on soil health. So this is the field plots across the 4 years In each year, we have about 20 crops across the 7 sites. At each site, the crops are selected to best fit the local conditions. So the results generated from this study will be uh, easily applied to different study region and be adopted by producers. In the last 4 years, the weather is quite different. For example, in 2020, we have adequate rain, have a great crop year. But in 2021, it's pretty dry, and that's very hard for some crops, particularly for canola. So these are results. To assess the crop adaptation, I select wheat, canola, and soybean, which are representative of cereal crop, oilseed crop, and annual legume crop. And all these 3 crops is growing at all 7 sites. So this is very clear that each crop responded to study sites differently. For example, soybean have highest yields at Carmen. However, at Carmen, and then they produced unexpected low yield for wheat and canola. In general, in black soil zone, they produce higher yields, and this dark brown soil, such as Lethbridge, they produce a lower yield because of water deficiency. Based on this variation, we found the wheat is more stable um, across different sites compared with the soybean. So this the crop adaptation for different crops. How about the cropping system adaptation? I use annualized canola equivalent yield, which was calculated based on the crop price and crop yields. So this figure shows that there's a significant interaction between study sites and cropping systems. For example, this red is a high risk and high rewarding system. They produce the highest system yield at Carmen site, but produce a relatively low yield at other sites. So this interaction indicates that there is no single cropping system that could fit all study sites. If I combine all 6 different cropping systems at each site, as indicated by this pink star, the comb sites produce the highest system yield, and the Lethbridge produced the lowest yield. Among the cropping systems compared with control, both POS is a pulse or oilseeds intensified rotation, or the market-driven system produce a higher yield. However, as expected, the green manure system produced lower yield than control because there are no production at the green manure phase. However, the green manure is beneficial for soil health improvement. However, such benefits may not show up in a short period of time. Same thing for diversified cropping system, the benefits may not show up. So it's important to conduct a relatively longer study to demonstrate the benefits of green manure based system and diversified cropping system. For economic returns, we found that net returns has a large variation, large difference between among different sites or among different treatments. In general, we found the market-driven system produce the highest economic returns. However, we need to be aware that in the long term, this market-driven system might cause soil health problem, also weeds or disease problem. In addition, in these market-driven systems, they have higher chemical inputs such as fertilizer and pesticides. So this may have a large negative effects on environments. So we need to balance the short-term economic benefits and long-term sustainability. For yield stability, I use coefficients of variation to assess the stability. So here we found that the POS system has a higher yield and a higher stability. In contrast, there's a high risk and high potential rewarding system, a lower yield and lower stability. To assess how cropping system respond to different environments, I use Finley-Wilkinson regression coefficient. The results show that green manure system has a lower coefficient, means they're less responsive to change environments. In contrast, this market-driven system has the highest coefficient, means they are more responsive. They're suitable for high-yielding zones. We recommend that we should uh, maximize yield for high-yielding zones and a stabilize yield for low-yielding zones, and then balancing the yield and stability for average yielding zones. So this is lead to my preliminary summary. Again, this is a first 4-year crop rotation study. Theoretically, right now is a transition period, so there are no solid conclusions can be made. Their long-term study is needed. Also, an cropping system should be optimized by multiple indicators and also considering the short-term economic benefits and long-term sustainability. It's important to stress that cropping system study needs a relatively longer term to assess the true cropping system effects so that we could optimize the cropping system on the Canadian prairies. With that, thank you for your attention.